Hi guys, welcome back to my channel. In my previous episode, we take a look at how to write chemical formulas. Today we are going to be looking at oxidation states. How do we find the oxidation states of some elements in a compound? Altogether, before I jump into this class, I would like you guys to please subscribe to my channel and please click on the like button. The like button under this video to like my video. I will surely wait behind so I can do that now. Thank you. Let's continue. Now, you see, when we say the oxidation states, it simply means the charge carried by an element. That's what we call what? Oxidation states. Now, there are some rules that is guiding writing of oxidation states of different elements. And one of the rules are given on the board. The first thing is that, you see, oxidation states of group 1, 2, 3 are constants. Please note, the group 1 elements, the group 2, and the group 3 elements. We know that what each of these are the metals. Altogether, the group 1 elements are the alkaline metals. The group 2 elements are the alkaline earth metals. The group 3 elements are the aluminium families. Altogether, each of these are also what? Metals. Now, the oxidation states of the group 1 elements, you see, group 1, 2, and 3, the oxidation states is always their group number. For group 1 elements, example is sodium, the oxidation state is +1, group 2 is +2, group 3 is +3. Altogether, now, number 2, you said that what? All metals have a positive oxidation state. All metals, they have a positive oxidation state. But please note something. You see, majorly, all the transition metals, with the exception of scandium and zinc, altogether, because scandium and zinc are not transition metals. Altogether, all transition metals they are also metals, right? But one thing about transition metals is that they have a variable oxidation state, unlike all these metals here. That their own oxidation state is constant. Transition metals, their own oxidation state is not constant. For example, manganese can have an oxidation state of +2 and it can have an oxidation state of +4. Now, at the same time, we can also have copper that has an oxidation state of +1. At the same time, it has an oxidation state of what? +2 in different compounds. Altogether, each of these are transition metals. Iron have an oxidation state of +2 and also another oxidation state of +3 in different what? Oxide. Altogether, now, the third one is now, non-metals have a negative oxidation state. Non-metals, they all have a negative oxidation state. Where are the non-metals from? Started from the group 5, 6, and 7. They are non-metals. Majorly, group 5, 6, and 7, they are pure non-metals. All these non-metals, they have a negative oxidation state. All non-metals. Altogether, now, we know that the number of the oxidation state that they have depends on their group. For example, now, the group 5 elements, which are nitrogen group. The nitrogen group, for example, know that group number is number 5. The oxidation state should be -3 because they need 3 electrons for them to complete their octet structure. So the oxidation state of nitrogen is -3, while that of oxygen is -2. That of what? Group 7 is -1. Altogether, all these are non-metals, so they have what? Their own oxidation state is given as their group number also. Now, take a look at this here. Oxidation state of hydrogen. As you know that hydrogen sometimes it can behave like metal. Sometimes it is going to behave as non-metal. Altogether, so you see, hydrogen has different oxidation states. Majorly, the oxidation state of hydrogen is always +1, but it changes. When hydrogen is found itself in an hydride, hydride is always formed when hydrogen reacted with metals. So when hydrogen reacts with metals, it forms its hydride. So in the hydride of hydrogen, oxidation state of hydrogen is not +1 anymore. It is now -1 in its hydride. For example, in sodium hydride, NaH, or calcium hydride, oxidation state of hydrogen in this case here is -1, while sodium is +1. Altogether, because it is showing that hydrogen in this case, in hydride, hydrogen is more electronegative than sodium. That's why hydrogen is having -1, while in its normal state, in other compound except hydride, hydrogen is having +1. The same thing goes to oxygen. The fifth one said that what? Oxidation state of oxygen is -2. Oxygen always have the same oxidation state of -2 in all compounds, except when it found itself in peroxide. In peroxide, or when it forms a compound with fluorine. When oxygen reacts with fluorine, as we know that fluorine is the most electronegative element that we have on what Earth's. Now, if oxygen reacted with fluorine, the oxidation state of oxygen changes to +2 when it reacted with fluorine. While when oxygen forms its own peroxide, for example, hydrogen peroxide or sodium peroxide, when oxygen forms any of this peroxide, the oxidation state of oxygen is always -1. -1 in its what? Peroxide. But when it is in with fluorine, it forms an oxidation state of +2. That is that about that. Now, you see, how do we now calculate oxidation states? That is for 6. I don't think I put it there. You see, oxidation states, the sum of all the oxidation number in a compound is always equals to 0. If that compound is a neutral compound. For example, this is what I'm trying to say here. Let me try to remove this. Now, the next one is that the sum of all the oxidation states. For example, now, I have H2O. The oxidation state of hydrogen in water, H2O. Now, we check here, this water here is a neutral compound. A neutral compound is a compound that does not carry charge. Altogether, so how do we now find oxidation state? Let me give an example. I said, find the oxidation state of hydrogen in H2O. What is the oxidation state of hydrogen in this? As you know that what? Oxygen has an oxidation state of -2. Want to know the oxidation state of hydrogen in this place? How do we calculate it? Since this is the neutral oxide, then the sum of all the oxidation states here must be equals to 0. That means oxidation state of hydrogen times 2, because we have 2 atoms of hydrogen here and 1 atom of oxygen. So oxidation state of hydrogen times 2 plus oxidation state of oxygen, we have 1, right? Everything equals 0. As I'm looking for oxidation state of hydrogen, we have what? 2 hydrogen here, right? Plus oxygen is having an oxidation state of -2, don't forget. So this is -2 equals 0. So 2H minus 2 equals 0. This should be equals to 2H equals to 2. Now we are having oxidation state of hydrogen to be equals to +1, which is highly correct. Altogether, so if I have a neutral compound, the sum of all the oxidation states should be equals to 0. Altogether, but if the compound that I have is not neutral, for example now, I have MnO42-. This is not a neutral compound. This is a radical. Oxidation state, the sum of all the oxidation states in a radical, in a compound that is what? Radical, is equal to the power that is carried by that compound. Or let me say the charge that is carried by that what? Compound. Now, in this case here now, I said, find the oxidation state of manganese in MnO42-. What will be the oxidation state of manganese? Here I can have what? Summation of manganese plus oxygen. In this case here we have 4 atoms of oxygen, that is times 4 equals to -2. Here I can have what? Manganese, because I'm looking for it, plus this one should be equals to -2 times 4 equals to -2. Now, if I find this is Mn minus 8 equals to minus what? -2. Tetraoxo manganate 7. Not, this is not 2, this is minus 1, this is minus 1, this is minus 1, yeah, this is minus 1, this one is all minus 1, minus 1, minus 1. Now, if you find this, I'll be having what? Minus 2 times 4, that is minus 8. Mn minus 8 equals to minus 1. We have what? Mn to be equals to minus 1 plus 8, which is equals to plus 7. Oxidation state of manganese in this compound is plus 7. This compound is pronounced as tetrahydro manganese 7. Altogether, that's tetrahydro manganese what? 7. Altogether, now that is the oxidation state of manganese in this compound. How do we find it? Just sum up all the oxidation states, then equate it to the oxidation state of the compound itself and the charge that is carried by that compound. That is how we look for the oxidation state. Thanks for watching this episode. Please get your book, get the past question. I recommend you to get this past question, which is what JAM series Remis. You can get this past question. Also, it makes your work easier. It is very easy for you to just stroll through from one topic to another topic, and it will make you can easily get high score in your JAM. Meet me in my next episode. Thanks for watching. Please don't forget to subscribe and like my video. Thank you.